Hello friends. Yes, we are studying photochemistry. In that photochemistry, we already studied laws of photochemistry and quantum yield. And on this basis of laws of photochemistry and quantum yield, today we will deal with some problems in photochemistry. It is problems based on laws of photochemistry and quantum yield. Okay? Yes, we will see the problems. Now, take the first problem. Yes, read it carefully. What is given here? 0.02 molar colored solution absorbs 65% of incident light in colorimetric experiment. Okay. What would be the concentration of solution which has a transmittance of 43% with if same cell is used? Yes, read once more. Concentration of solution is given. One concentration is given. Has a solution absorbed 65% of radiation. Okay. Another solution which has a transmittance of 43%. Okay. Now what is its concentration? You have to determine its concentration. Okay. Now initially while starting the solving of problem, you have to write given quantities with proper physical interpretation. We know the Lambert's law or Lambert-Beer's law. We have to use here Lambert-Beer's law. Concentration is given. Yes. Now concentration is given. We require two different concentration. One concentration is given. We have to determine another concentration. Yes. Okay. Means C1 is given as 0.02 molar and you have to determine another concentration C2. Okay. Now what other quantities are given? Another quantities absorbed 65%. Yes, we know optical density D is equal to epsilon Cx. What is this optical density? Log of I0 upon I. I0 is the initial intensity and I is the intensity after passing through the solution. After passing through the solution, it is the transmitted light. I0 upon, you can say as a IT. Now what is given here? First of all, absorbs 65%. From that means I0, it is given in percent, means I0, it is 100. Yes. And for first experiment, I transmitted light is 100 minus 65, that is 35%. Yes, 65% is absorbed. Transmitted light is 35%. Yes, and in second experiment, transmitted light is, yes, it is also given 43%. Two solutions having two transmittance, one concentration is given, another concentration has to be determined. One more example. When the same cell is used, we are using same cell, same container, means thickness is constant. Okay, here thickness is constant. We are using same solution, that's why epsilon is also constant. Means we have to use this equation, log of I0 upon I is equal to epsilon Cx. For first solution, 1, 1, 1, 1. For second solution, we have to use log of I0 upon I 2 is equal to epsilon 2 C2 x2. But x1 is equal to x2 because we are using same cell, and epsilon 1 is equal to epsilon 2 because we are using same solution. Epsilon is the molar extinction coefficient. It is constant and it is a characteristic of that particular substance. Since here we are using same cell and same solution, same substance, that's why epsilon is also constant. x1 is equal to x2, epsilon 1 is equal to epsilon 2. Then take simple ratio of these two. Log of I0 upon I for first solution divided by log of I0 upon I for second solution is equal to C1 upon C2. Epsilon 1, epsilon 2 get cancelled, x1, x2 get cancelled because they are same. Yes, now put the concentration value and all the given values. Okay, log of 100 upon 35 divided by log of 100 upon 43 is equal to C1 is given 0.02 and C2 you have to determine. Okay, take the ratio these two, log of 100 upon 35. If you calculate this value 100 upon 35, it will be 2.8571 divided by log of 100 upon 43, it will be 2.3256 is equal to 0.02 upon C2. Excuse me. Now take the log of these two values, log of 2.8572. You can determine this log on calculator as well as with the help of logarithmic table. It will be, characteristic will be 0.4559 divided by 0.3665 is equal to 0.02 upon C2. Okay. You can determine here C2. Therefore, C2 is equal to, take this C2 to this side and all this to this side, 0.02 into 0.3665 divided by 0.4559. Therefore, C2 will be 0.01608 molar. if you are asked comparative problem, here what is given? Again see, two solutions are given and two absorbances or transmittance. Absorbed light is 65%, here transmitted light is 43%. And here we are taking I. This I is the transmitted light, mind well, it is not absorbed light. Initially when x is equal to 0, and here this after x. Both this I is a transmitted light, due to which this is taken as it is, and we have to consider here absorbed light is 65, means transmitted is 35%. Yes, if such comparative problem is given, two solutions, then you have to take the ratio. Yes, good. Got it? Yes. Next problem. Read this problem. Intensity of light when passed through 1 into 10 raised to minus 3 meter path length. Path length is given here. X is given here. Path length of cell containing this solution. Concentration is again given. Yes. Intensity of light is reduced by 15%. Reduced by 15% means 15% light is absorbed, transmitted light is 85%. Reduced by, if it is given reduced by, but here what is given? Reduced to. Read this. Sorry. Yes. Reduced to 15%. 100% light is bombarded, it is reduced to 15%. Means transmitted light is given of its initial value. Calculate the optical density and molar extinction coefficient of the sample. Okay. Yes. Now what is given? Initial light has passed through, म्हणजे x is given here, 1 into 10 raised to 3 meter. Path length is given. Again concentration is given, 0.05 mole per dm cube. When it is given in percentage intensity, you have to take I0 as 100 and I as a transmitted light. You can write IT also. You can take this IT also. Transmitted light is 15%. These are the given quantities. And what you have to determine? Molar extinction coefficient as well as optical density or D. Okay. Now you have to choose these two. I0 and I is given or IT is given. Means you have to choose the formula, that is Beer's law, log of I0 upon I is equal to epsilon C x. Therefore log of I0 is 100, IT is 15 is equal to epsilon C is given 0.05 into T is given 1 into 10 raised to minus 3. This x thickness is given 1 into 10 raised to minus 3. Not 3, minus 3. Okay. Therefore, you can solve this. Yes. Log of 100 upon 15. What will be the value? 100 upon 15. Yes, it will be here log of 6.6667 is equal to epsilon into, now calculate this value, 0.05 into 10 raised to minus 3 means 5 into 10 raised to minus 5. It will be 10 raised to minus 2. 5 into 10 raised to minus 2 and into 10 raised to minus 3 means it will be 5 into 10 raised to minus 5. Okay. Now take the log of 6.6667. What will be its value? 0.8239 is equal to epsilon into 5 into 10 raised to minus 5. Okay. Now, therefore, epsilon is equal to 0.8239 divided by 5 into 10 raised to minus 5. You can determine the value of epsilon. Epsilon is equal to 0.8 divided by 5 into 10 raised to 5. Minus 5 will becomes 5. 0.8 divided by 5. What will be the value? It will be 0.1648. Therefore, the value of epsilon will be 1.648 into 10 raised to 4 into 10 raised to 4. This will be the molar extension coefficient. Okay. Now, what is again asked to calculate? Optical density, D. Again, we know the formula. D is equal to epsilon C x. Yes, we know the epsilon, 1.648 into 10 raised to 4. Concentration is given 0.05. X is again given 1 into 10 raised to minus 3. You can determine or you can multiply these values. 1.648 into 0.05 and the value of D, optical density, will be 0.824. Means we will get this optical density as well as extinction coefficient. Okay. Yes. We will go for next problem. Calculate nu, lambda, nu bar, energy per molecule, energy per mole for radiation of wavelength. Actually, this is not for molecule, it should be per quantum. And this energy per, not mole, it should be per Einstein. Okay. What is given? Radiation of wavelength. We have only lambda. 2000 angstrom. Again, what is given? First of all, write what are the quantities, given quantities. Avogadro's number is given also here. Na 6.023 into 10 raised to 23. Again, Planck's constant H is given 6.624 into 10 raised to minus 34, and velocity of light is given 3 into 10 raised to 8 meter per second. Okay. Now what is to be calculated? We have to calculate nu. We know the general equations. Nu is equal to C upon lambda. Nu is equal to C upon lambda. C is given velocity of light. Simple problem. 3 into 10 raised to 8 divided by lambda. This is in meter per second. And lambda is given in angstrom. 1 angstrom is equal to 10 raised to minus 10 meter. Therefore, lambda will be 2000 into 10 raised to minus 10. Okay, solve this. It will be 1.5 into 10 raised to 15 hertz or cycles per second, the unit of frequency. Then again nu bar is to be determined. Wave number, it is the reciprocal of wavelength. It is the reciprocal of wavelength. It will be 1 upon 2000 into 10 raised to minus 10. You can solve it. It will be 5 into 10 raised to 6 per meter. Okay, now we have to determine energy per quanta. E is equal to hc upon lambda. Therefore, E is equal to, value of h, value of velocity of light, and lambda is given. Value of h is 6.624 into 10 raised to minus 34. Mind well, whatever may be the value, given value, you have to take the same value. Don't change. If you know the value differently, sometimes what happens, for simple calculation, it is given as 6.6 into 10 raised to minus 34. This 24 is not given. Then you have to use whatever may be the given value. Velocity of light is 3 into 10 raised to 8 meter per second divided by lambda in meters, 2000 into 10 raised to minus 10. Okay, if we solve this, it will be 9.936 into 10 raised to minus 19 joules. This is energy per quanta, energy of one quantum of radiation. And per Einstein energy, it is nhc upon lambda. N, you can take Na, Avogadro's number. Means simply multiply this value with Avogadro's number. Means 9.936 into 10 raised to minus 19 into Avogadro's number 6.023 into 10 raised to 23. The value will be 5.984 into 10 raised to 5 joules. Yes, it is not necessary to put again H, value of C and lambda. Already we have calculated this value. Just multiply with Avogadro's number. You will get the required value. Yes, got it? Okay. Next problem. A certain system absorbs 5 into 10 raised to 6 quanta of light per second. Yes. On irradiation for 25 minutes, absorption is given per second. This much quanta of radiation is absorbed in 1 second. But the experiment is carried out for 25 minutes. Okay. Then what happens after 25 minutes? 0.003 moles of reactant was found to be reacted. We have a number of molecules reacted. Moles reacted, not molecules. Moles reacted. Calculate the quantum yield. Calculate quantum yield. Either we have to consider mole or we have to consider molecules. Okay. Write the given quantities. Certain system absorbs 5 into 10 raised to 6 quanta of light per second. But the experiment is carried out for 25 minutes. Therefore, total number of quanta absorbed is equal to this per second into total number of seconds. 25 minutes means 25 minutes into 60. It will give number of seconds into per second 5 into 10 raised to 16. It will give total number of quantas absorbed. Calculate this value. 25 into 60. It will becomes 1500 seconds into 5 into 10 raised to 16. Total number of quantas absorbed will be 7500 into 10 raised to 60, or simply you can convert 7.500 into 10 raised to 123, 10 raised to 19 quantas are absorbed. Yes, we get total number of quantas absorbed in a given time, and we are given with what is given here, moles reacted. We have to determine molecules reacted. Moles reacted. It is 0.003. 0.003. Therefore, molecules reacted one mole contains Avogadro's number of molecules. Means we have to multiply with Avogadro's number into 0.003. What is the value of Avogadro's number? It is again given. That's why it is given here. 6.023 into 10 raised to 23. Therefore, 6.023 into 10 raised to 23 into 0.003. Okay. What is its calculation? It will be 0.18069 into 10 raised to 23, or you can simplify it 1.8069 into 10 raised to 22. Okay. Here we have number of quantas absorbed. Here we have number of molecules reacted. You can determine the quantum yield phi. Number of molecules reacted in given time divided by number of quantas absorbed in same time. Okay, take the ratio of these two. Number of molecules reacted 1.8. What is the value? 1.8069 into 10 raised to 22. Solve it simultaneously. Then and then only we will get the results. Yes. Divided by number of quantas absorbed. Number of quantas absorbed 7.5 into 10 raised to 19. 7.5 into 10 raised to 19. That will be 19 will go upward. It will be minus 19. Means it will become 10 raised to 3. Okay, it will be 10 raised to 3. Okay. Now take the ratio 1.8 upon 7.5. 1.8069 divided by 7.5. It will be 0.24092 into 10 raised to 3, or you can convert it to 240. 1, 2, 3. This will be the quantum yield. Yes, got it? Is it correct? Yes. Yes, got it? Yes, thank you.